Well, we're still picking up Mike pretty well here. We're going to go up this industrial park, see if we can pick him up there. Not bad. Going up into this industrial park. Picking up Mike quite well. To say that I've been influenced by this particular publication by the ARRL by Doug DeMaw and Wes Hayward is an understatement. W7ZOI, W1FB wrote this thing back in the 70s, and this was really what got me into solid state design. I had been doing a lot of tube circuits and some simple solid state circuits in high school, and by the time I got to college I started to get more interested in a little more complicated circuits. But I really have never built superheterodynes. I've been sticking with regens and simple receivers, crystal sets, things like that. But my first superhet, and I probably showed this off before, was a 40-meter QRP rig built from a lot of techniques that were from that book. A simple crystal-controlled two-stage transmitter using bipolar transistors. I think I used some type of a CB transistor in the output. And a simple receiver using a dual-gate MOSFET, which was all the rage at the time. No RF amplifier, just a dual-gate MOSFET itself. And it went into, I think, a 1350 television IF chip, which was another very popular chip at the time. And then another dual-gate MOSFET as the product detector, and then maybe a stage of audio, a bipolar, and an LM386 output. So that, you know, with a little VFO just for 40 meters. So crystal controlled transmit, VFO on the receiver. That's the most complicated superhet that I've really built. So that was about 1981. Now from that, when I started to get interested in low frequencies, it must have been the early 90s, like 1990, 91, 92. And it was these weird, freaky guys that would put on these 1 watt input power part 15 beacons in the 160 to 190 kilohertz range. And I wanted to get in on that. I was late to the game, but I did want to get in on that. So I decided that I was going to make my own beacon. And I decided to use a CMOS divider off a crystal operating up in the HF region, probably 4 or 5 megahertz. And I divided it all the way down to, I think, 187 kilohertz. Drove that into a MOSFET transistor like an IRF 530 or 540, and produced my 1 watt input power. Had a nice filter on the output so it was pure. Made a loading coil and an antenna in the woods, and I had my own beacon. So that's how I got interested in the low frequencies. This is about 91, 92 time frame. So after putting this beacon in the woods, putting out a few radials, an interpretation of the 50-foot of antenna length, pulled up into the trees, I figured out I don't have any way of listening. I have no receiver. What am I going to do to receive the low frequencies, specifically the 160 to 190 kilohertz band? So that's when I decided to build my second superheterodyne receiver. And I dug this out of the closet. It's still covered with dust. This has not been turned on in 15 or 20 years. Now it has been turned on this last week, prepping it for this video, because it was in the wrong band, and I wanted to make sure it could cover the 630 meter band. So I have done the modification to the VFO to make sure it can cover 630 meters. So this receiver was built cookbook style, all surface mount on one of those boards that just has pads all over it. And I'll show you that. You might be a little bit shocked at this construction technique, but I'm going to show you what it looks like. Let me turn it off. Disconnect the power supply charger. And I say power supply charger because, as you can see, it's got a lead acid battery inside. Look at the goodies in this box. First of all, we have a front-end RF amplifier. This is like a low noise amp up front. Goes into an SRA1 mixer. This is one of those diode mixers, operated backwards. So we're coming in the IF port and using the RF port as the IF output, going into a 4-pole ladder filter, and then into various circuits, BFO. It upconverts to 4 megahertz. And it's got all kinds of interesting circuits. And this was built, and I just kept adding circuits to it as I went. Also, there was this little counter chip available at the time, and I put a counter over here. This counter chip basically just reads the VFO frequency, which, by the way, is not exactly the frequency the receiver's on, but it's in the ballpark because, you know, the ladder filter, of course, probably is a few hundred hertz off the frequency that's displayed. So let me put my charger back on because I can assure you that lead acid battery is deader than a doornail after being in this box unpowered for the better part of 20 years. The lead acid battery is now gone high impedance, as they do. Let's see if we're in the 630 meter band. Yeah, we are. And I've got a red bezel on order to put on this to dress it out a little bit, because if I went to all the work to change the VFO, I'm going to give it a nice bezel so it looks a little bit better. So what else? As soon as I built the receiver and hooked it up to an antenna in the yard, the next thing I determined was I can't hear anything but noise. I built the best noise receiver in the world, and I picked up all kinds of... So that's when I decided I needed some type of effective antenna system where I could fight this noise problem. And the first thing that came into my head was, let's go to the car. I'm going to drive to a quiet spot. So I needed to have an antenna that would go on the car, something I could deploy easily. This has a mag mount. So today we call this an active whip antenna. I had a MOSFET and probably a couple transistors that I put in the project box. And if I attach this thing, okay, it wants bias, right? Because you need to power it through the coax. So there is a bias T that feeds power up into the active whip. Okay? The active whip is doing its job. Now, if I happen to have an oscillator going in the other room, we might be able to tune it in. There it is. I have a little low power oscillator into a 1-foot piece of wire. I'm picking it up. Now I built some things in here, like as you can see it has a hang AGCS meter. It's got an active filter. You know, different things built into it. So we're going to play a little bit with this thing, take it out into the car, and see if we can pick up some 630 meters. Bonus, I added a toggle switch that allows us to do the 2200 meter band as well. So we can also tune 2200 meters with this. I do have to touch up the preamp in the back to peak it at 2200, but it's pretty close. So I've taken my simple 160 to 190 kilohertz receiver and have converted it to a 2200/630 meter receiver for the car. we'll see how this thing operates after 20, 30 years. Now, in preparation for taking the equipment out to the vehicle and doing our little drive-around test tonight, I just want to cover a couple things. First of all, because the battery in this receiver is so weak, I'm going to be using a vehicle adapter plug that will plug into the cigarette outlet. There's a couple of ferrite beads on the cord so we don't get some noise coming that direction. And of course this cord can act like an antenna, so we don't want the car's electronics to be transmitting on the DC cord. Also, the VFO in this unit, which operates in the 4 MHz region, it is uncompensated. Not that that would make much difference, because inside, you know, we're sitting around 60 degrees Fahrenheit, and outside we're at about 10 degrees Fahrenheit. It's very cold here in New Hampshire in the wintertime. And here's the question I pose to you. What makes more sense? Taking the equipment out to the car and letting it stabilize at the car's temperature, and then starting the car, or starting the car ahead of time, letting it warm up, and quickly transporting the equipment to the car? What makes more sense to you? Think about it. But I will assure you, this oscillator will change over temperature, and as the temperature changes, the frequency will drift. And until everything stabilizes, I won't have a stable system. The only way to really have stability with a VFO under those conditions is not really compensation, because you can't possibly get everything to heat up at the same time. I suppose you could use a heater and heat the box and insulate it, but more likely a phase lock loop approach is the way to go. So if you could phase lock the VFO so maybe it tuned in small increments, or at least you could phase lock the oscillator, that would make a lot more sense. So this is a very primitive receiver compared to modern receiver, but this is what I could put together back in the early 90s, and we'll see if we can get it stable enough to work in the vehicle. I'm up on a dirt road on a little hill. I like this road because there's no power poles at all on it, so it's nice and quiet up here. Now again, I'm using the 3-foot active whip. The active whip is just on top of the roof. Receiver's quite stable. I've added a control, since you've seen this before, a BFO control, and I did that with a varactor that I've added to the warping the crystal on the BFO. It works quite well. So I can set it up here to try to do some decoding of whisper, because that's all done at high frequencies. You're in the USB mode, and it, you know, it's occurring up around 1500 to 2000. Well, actually not even that high, but a lot higher than down here, where Mike is transmitting down here. And you know, you want to have the BFO set so it works good with my active filter I've got in there. But there's absolutely no trouble picking them up here. It's nice and quiet up here. It just shows you that going mobile to find a very quiet spot is really the way to go. He is very loud here in New Hampshire up on this dirt road. So Mike is really pounding in here, W3TS. No trouble whatsoever. So we're still picking up Mike pretty well here. We're going to go up this industrial park, see if we can pick them up there. Not bad, going up into this industrial park, picking up Mike quite well. We'll just go up here and turn around. It's a nice hill up here. Nice to know I can pick this up on this hill. I believe these are underground utilities. Oh yeah. I'm up here in an industrial park, just sitting up here in an industrial park with the mobile receiver and the active whip. Definitely armrest copy here in the Maxima. Wow, some very strong QSB coming through. Just faded right out there. It's a little bit of altitude here. This is a good spot. And I think the underground utilities work very well at suppressing noise. So that was a wild ride, but I wanted to give you a flavor of the experiences that I used to have trying to pick up my beacon. Because when you were in that LowFER world of 1750 meter beacons, it wasn't like you were just hearing beacons all the time. I was concentrating on just being able to hear my beacon outside the yard. Literally, I could go down the block and not hear the beacon when I started. And one of the keys to picking up the beacon, beyond having a receiver and something on the car to be able to go further and further away, I had this RF milliammeter. This really was the secret. Every time you added a radial or improved the match, you would see this creep up. and that was just more fire in the wire, more current into the antenna. This was the whole secret to being able to improve the 1750 meter beacon. was my signature, and it was done with CMOS IDEA that I put together, just a kind of a synchronous logic circuit. It wasn't even a micro. At its high point, I could pick up the beacon 35 miles away, going 65 miles an hour on Route 495 down in Massachusetts. So I went from just being able to go down the block and lose the beacon to being able to have a good ground wave signal with it. The whole secret to that was the receiver and the active whip. Hope you've enjoyed this kind of retrospective video on some old equipment. Don't ask me for schematics because I have no idea what I've built. I will give you one thing though. In the next video, we're going to go through how to build a good solid VFO, one that doesn't drift. And this is an uncompensated VFO, so it should be an interesting discussion.